Hello.
Hello?
Yeah. Can you hear me?
Yeah.
Okay, so you wanted to discuss Menelaus theorem.
Yeah.
Okay, is Shiva's theorem clear?
If possible, yes.
I don't know. Is it clear for you?
Siever's theorem?
Hmm?
Uh, yes. More than Menelaus theorem.
Okay, maybe we'll discuss it towards the end. So first of all, we'll go to Menelaus theorem. So what it says is given triangle ABC, a straight line intersects AB, AC, and the extension of side BC at these points D, E, F respectively. Then if the straight line intersects it like this, then we have the following relation: AD by BD multiplied by BF by CF multiplied by CE by AE is equal to 1. So first of all, we have to draw the figure and understand what is going on. So let's see. A, B, C, and extend this BC side a little bit. And we have a straight line like this, okay?
Mm-hmm.
So the straight line cuts AB at D. So this is D. It cuts AC at E. And it cuts the extension of BC side at F. Okay?
Mm-hmm.
So basically, the condition of the theorem is that if there is a straight line like this that cuts all three sides, two of them inside and one of them outside the triangle, right?
Yeah.
Then we have this condition. Now, you need to be able to remember this condition. So the way to remember it, do you have any idea? How would you
Um,
remember it?
like it's like I saw something where you like look at like you start from a point and then you keep going, like based
Right.
on what you ended.
So the way to remember it is this. So imagine the triangle. And imagine that instead of this point F being outside, it was somewhere here, okay?
Mm-hmm.
Everything else is same. The only thing that you are imagining is F is somewhere here, okay?
Yeah.
And D and E are somewhere here, okay?
Mm-hmm.
Then what you do is you have to go in a particular order, either counterclockwise or clockwise, okay?
Yeah.
So you start from any point, let's say B, let's say A. So you say AD by BD, right?
Mm-hmm.
So AD by BD, then BF by CF, then CE by AE. Do you understand?
Yeah.
For this to work, you have to imagine this point F to be inside, okay?
Mm-hmm.
AD by BD, BF by CF, CE by AE, the product of these. If I wrote it in the opposite order also, it would work. You would get
Mm-hmm.
AE by CE, CF by BF, and BD by AD,
Yeah.
right? So
Yeah.
basically, you are saying that the D, E, and F, the 3 points, are dividing the sides in some ratio, right?
Yeah.
And you're writing each ratio and saying product of the ratios is 1, right?
Yeah.
So AD by BD is 1 ratio. Now, technically, F is outside, okay?
Mm-hmm.
So it is like an external division, BF by CF, right?
Yeah.
But the
Mm-hmm.
better way to imagine it would be if F was inside, it would be obvious it would be BF by CF, right?
Yeah.
So it is still BF by CF, but it's an external ratio, right?
Yeah.
And then it is CE by AE. And the product of these is equal to 1. Okay.
Yeah.
So now this result is true both directions. Okay. So if a straight line intersects the three sides like this at DEF, then this result is true. And if this result is true, you know that, then you can say that the 3 points DEF are collinear.
Yeah.
The opposite is also true. So if this result is true, then the 3 points E and F can be joined by a single straight line.
Hmm.
So it works both ways.
Yeah.
The proof of this theorem can be done by similar triangles and areas. I don't want to do it because proof you can find anywhere. So you can just search online and you'll get the proof. There are many ways to do the proof. Okay.
Okay.
So what we will focus on is like applying it to different problems. Okay.
Hmm.
Because
Okay.
that is the thing that you will have to actually do. So let's start off with this problem. In triangle ABC, D is a point on AB and we have AD by DC, AD by AC is equal to AC by AB is equal to 2 by 3. Now M is the midpoint of CD, midpoint of CD, while AM extended intersects BC at E. And you have to find the ratio of CE by BE. So I will not do anything right now. You try it
Hmm.
out first and then we will see. If you are getting it, great. But try to apply Menelaus theorem and see if you can figure it out.
Um,
Hmm.
I got I got 4/9.
That's correct. 4 over 9 is correct.
Hmm.
Is it clear what is happening?
Yeah.
Or do you want me to discuss this more?
Um, Sorry, just give me 1 minute.
Right.
Okay, yeah, I got it.
Sure, no, we don't need to discuss it, or do you want to
No.
discuss?
Mm-mm.
Okay, so basically you're applying Menelaus theorem in which triangle?
Um, DBC.
BCD, right?
Yeah.
On triangle BCD, that triangle you have to apply Menelaus, right?
Yeah.
And if you did the ratios properly, that's why you've gotten the correct answer, right?
Yeah. Mm-hmm.
Okay, let's go to another problem. Given triangle ABC, D is a point on BC such that AD bisects angle A. E and F are on AB and AC respectively such that DE and DF bisect angle ADB and angle ADC respectively. Now, if EF extended intersects the line BC at point P, show that AP is perpendicular to AD. So this is not as trivial as the previous one.
Mm-hmm.
So you might have to take a little more time and think about it carefully, but try it out, see.
Right, P is on the extension of BC, right?
EF extended intersects the line BC at P. Okay. This is the rough figure. I have not marked which angles are bisectors. Actually, this is
Mm-hmm.
a bisector, this is a bisector, and this is also a bisector, right?
Mm-hmm.
Obviously, the figure is not perfect, but whatever.
Mm.
You have to use angle bisector theorem.
Yeah, yeah. Then I wrote my side lengths like using variables.
Ideally, that is not recommended because then they will not cancel out very nicely.
Mm.
If you just keep using letters and label everything, no, that will be better, I think, for you.
Like AE.
Right. So don't call
Okay.
them X and Y. No need to do that.
Okay. So let me.
So Menelaus theorem is obvious on triangle ABC, right?
Yeah.
So from there we'll get a result like this. Let me apply it with respect to this point. So AE by BE. Then I'll imagine point to be inside here. So it will be BP and CP, right?
Yeah.
So BP by CP multiplied by CF by AF.
Yeah.
So that is the first thing that we get. Because this line is there and this line is cutting the two sides internally and one side externally, right?
Mhm.
Now we know many things, like we know DE is a bisector, DF is a bisector, right?
Yeah.
And we also know that AD is a bisector.
Yeah.
So if you think of applying angle bisector theorem, you can say that with respect to DE as a bisector, we know that the ratio in which it divides this side, right, will be the
Yeah.
ratio of AD and BD, right?
Yeah.
So basically, we can say that AE by BE should be AD by BD.
Yeah.
That is one consequence.
Hmm.
Similarly, we can say for DF bisector, we can say again AD by CD this time, right?
Yeah.
AD by CD this time should be equal to AF by CF.
Yeah.
Great.
Hmm.
And for the, okay, maybe this much will be enough. Kya? One second. Let me just see. Notice that A by B is already here and CF by AF is also here, right?
Yeah.
So A by B we can write as AD by BD. Okay, what we'll do is we'll use these two versions and see what is the product of A by B and CF by AF, right?
Okay. Hmm.
So A by B into CF by AF from angle bisector results we are getting is AD by BD multiplied by CD by AD, right?
Yeah. Hmm.
So we are cancelling this AD, we're getting CD by BD here, right?
Yeah.
So
Hmm.
we can remove these two from here and say CD by BD instead of them, right?
Yeah. Hmm.
So CD by BD times BP by CP, right?
Yeah.
Is equal to 1 is coming, right?
Hmm.
Now, for the main bisector AD, we can say BD by CD is equal to AB by AC, right?
Yeah.
So from there, we can say that CD by BD here will become AC by AB, right?
Hmm.
AC by AB into BP by CP is equal to 1, right?
Yeah.
So what we are getting now is BP by CP is equal to AB by AC, correct?
Yeah.
Combining Menelaus and the three bisector relations, right?
Yeah.
So BP by CP is coming out to be equal to AB by AC, by AC, right?
Yeah.
So then that means that notice that the same ratio, like P is again dividing the base in the ratio of BP by CP, right?
Yeah.
So that just says that it's an external bisector, no? External angle bisector of BAC, right? If it was an internal angle bisector, this result would have proved that AP is an internal bisector, right?
Sorry, why?
What I'm saying is, if it
Yeah.
was an internal point P, right?
Mm-hmm.
And if you got a result like this, BP by CP is equal to AB by AC, what would it have
Yeah.
proved?
P
That
is
AP is
like,
a bisector line, no?
yeah.
But we are getting something like that only, but it is outside. The ratio is worth an external point, right?
Yeah.
That tells us that it's an external bisector, AP.
Mm-hmm.
It's a bisector of the external angle BAC. What I mean by that is, extend this
Yeah.
angle's bisector is AP.
Yeah.
Why? That's a consequence of your normal bisector theorem only. You can prove it very easily. By the way, we'll prove it later. First, realize that that proves that AP will be perpendicular to AD, right? If AP is
Yeah.
external bisector, it
Mm-hmm.
automatically becomes perpendicular to AD, which is internal bisector,
Yeah.
right?
Yeah.
So all we need to understand this is prove that anytime you have an external bisector, it will divide the thing in the ratio, again similar thing.
Mm-hmm.
So yeah, I'm making this figure is not very good. A second. Right. So I know that these two angles are equal, and
Mm-hmm.
I need to find the ratio of BP by CP, right?
Yeah.
If you can prove that BP by CP is same as AB by AC, then that result that we have used is correct then, right?
Yeah.
So think about it. This is a bisector. So, okay, so BP by CP, BP and CP, right.
Mm-hmm.
We have to show this. Okay, 1 second. Hmm, if this angle is something x, then this is 180 minus x. So this is 90 minus x by 2. This is 90 minus x by 2, right?
Mm-hmm.
And right. Okay, let's draw the angle bisector from here also.
Mhm.
So this point becomes my X center, right?
Yeah.
X center B, right?
Hmm.
Or you can call it IB if you want. Correct. So this point is equidistant from this also and this also and this also, right?
Yeah.
So, okay, so bisectors are meeting here with the normal side. Okay, first I will do the case in a simple situation. Uh, let's take the example of a right angle triangle first and see what happens there. Maybe we'll get a hint of why it works.
Hmm.
So, like this is 90. This is equal to this A, B, C. So, let's say this angle and this angle are equal. So, okay. So, if this angle is X and X, you have here this will become 90 minus X, and this length will become uh, AC by PC is tan of 90 minus X, right?
Hmm.
Correct?
Yeah.
So we are getting PC is equal to AC by tan 90 minus X is cot X. So PC is AC tan X, right? Correct?
Yeah. Hmm.
Okay, now we look at the big triangle and we want to find PB also. Okay.
Hmm.
So these two angles are 2x. So therefore this angle must be pi minus 2x, right?
Yeah.
Correct. And
Hmm.
the overall angle here is becoming pi minus x, obviously, right?
Yeah.
And by, okay, so by sine rule, we can say, sine rule you know, no?
Yeah.
So in triangle ABP, I'm looking at sine rule, okay? So
Hmm.
I'm going to say PB by sine of pi minus x should be same as uh, AC, no, not AC, AP. I don't want AP. I can say this AB by sine of this, right?
Yeah.
AB by sine of 90 minus x, right?
Yeah.
So now I'm getting PB by sine pi minus x is sine x is equal to AB by cos x, right? I'm
Yeah.
getting PB is equal to AB into tan x, right?
Yeah.
Now see PB by PC ratio, right?
Hmm.
It is coming AC by AB, right? See,
Let's see. Okay.
PB by PC is becoming AB by AC, no?
Hmm.
See, the only thing that I have done here that is convenient is 90-degree, right?
Yeah.
Like I can do the same problem now. Now that I know that trigonometry will help me forget it, I can do sine rule without 90-degree also, right?
Yeah.
Like just remove this as 90-degree and I will just get this angle as something not 90 minus x, right?
Yeah.
And you can apply sine rule in both whatever triangles you need. This triangle you can apply sine rule with whatever angles you have. Similarly, the other triangle you can apply sine rule to get ratio of PC and PB, right?
Yeah.
You can try it out. I mean, I can also try it out, but it will come basically. The point
Hmm.
is that the logic of it is same as the interior angle bisector logic. Are you understanding what I'm saying?
Yeah.
So we have like this situation now like this, and we know that these two angles are equal, and we can again call them x and x, and we need the ratio of PB and PC, right?
Yeah.
We want to prove that it is equal to AB and AC, correct?
Mm-hmm.
Okay, so I need the side PC somehow. So I'll apply sine rule in this triangle, right?
Mm-hmm.
So what can I say? I can say PC by sine x is equal to which other version should I use? I should use this one and this angle, maybe, right?
Yeah. Mm-hmm.
AC by sine of whatever this angle is, APC, right?
Yeah.
Correct?
Uh, why? Yeah.
Okay, we can call it Y if you want. So PC is AC sine X by sine Y, right?
Yeah.
Now I'll do for PB first. So for PB, I'll need the triangle ABP, right?
Yeah. Mm-hmm.
And this full angle is obviously pi minus X, right?
Yeah.
So I'll
Mm-hmm.
say PB by sine pi minus X is equal to AB by again this angle, right?
Yeah.
You see now it is coming obviously.
Yeah.
So we are getting PB is equal to also AB sine X by sine Y, right?
Yeah.
And we are getting PB by PC is AB by AC,
Yeah. Mm-hmm.
right?
Yeah.
So that is the result that you're using. And now remember that even external angle bisector divides the extended side in the ratio of the sides, right?
I'm gonna ratio this.
You already know internal angle bisector theorem, right?
Yeah.
So it's just a same version of it, just for an extended side, right?
Yeah.
In the ratio of the
Oh.
sides. Is it making sense intuitively what is
Yeah.
happening?
Yeah.
So now, according to that, because we got that in the previous example, we got BP by CP is AP, AB by AC. From there, we concluded that AP is the exterior angle bisector of BAC, right?
Yeah. Mm-hmm.
And as soon as you know that, then the exterior angle bisector and the interior angle bisector are always perpendicular, right?
Yeah.
So that finishes off the problem. Is it clear?
Yeah. Yeah.
Okay. Then we look at this problem. In triangle ABC, M and N are points on AB and AC respectively, such that the centroid G of triangle ABC lies on MN, lies on MN. Show that AM times CN plus AN times PM is equal to AM times AN.
Okay.
Okay. Think
Mhm.
about it. You have 5 minutes. Try it out, see what you can get.
Mhm.
There are two cases here. One of them is really easy.
Mhm.
If you have drawn the figure with MN parallel to BC, that's obvious.
Oh. Oh, and
You,
then I test it for when it's parallel and when it's not?
there are two cases, right?
Yeah.
Because we don't know for sure whether it's parallel or not, right?
Yeah.
If it's not parallel, there is a separate case. If it's parallel, it's a separate case.
Hmm. Okay. Mhm.
Okay, let's talk about it. Uh, First, we can do the simpler case. That is the case where MN is parallel to BC.
Mm-hmm.
Let's say this is M and N parallel to BC and G lies on MN, right?
Yeah.
So G lies on it and this is like centroid. Okay, and call it D here. Now, okay. Now we have to show this thing, right?
Yeah.
Because it is a centroid, we know AM by AB, the ratio will be same as AN by AC because of parallel lines.
Yeah.
AM by AB will be equal to AN by AC. And because we know it is also equal to AG by GD, right?
Yeah.
Which is 2 is to 1, right?
Mm-hmm.
No, no, it is not equal to AG by GD because it will be equal to AG by AD, right?
Yeah.
So that will be 2 is to 3, right?
Mm-hmm.
So we know these are 2 is to 3, 2 is to 3, right?
Yeah.
So similarly, you can say that CN by AC is equal to BM by AB is 1 is to 3, right?
Yeah.
So if I have AM into CN and here this, maybe I should, okay, I have to prove this is equal to this. So AM can be written as 2 by 3 AB, right?
Yeah.
Multiplied by Cn can be written as 1 by 3 AC,
Mm-hmm.
correct?
Yeah.
Plus An can be written as 2 by 3 AC and Bm can be written as 1 by 3 AB, right?
Yeah.
So we are getting 2 by 9, 2 by 9, 4 by 9 of AC into AB, right?
Yeah.
On the left hand side. And AM was 2 by 3 AB, right?
Yeah.
And AN is also 2 by 3 AC, right?
Mm-hmm.
So the product of this on the right side is also this only, right?
Yeah.
So this is the easy case. Because of parallel lines, it's all obvious, right?
Yeah. Mm-hmm.
Now we will do the other case where you will have to use Menelaus.
Yeah.
Okay. So
Mm.
are you getting the hang of it? What is happening?
Yeah. I think
So
I get how to apply it better now.
what are you saying?
Like, with the trick you showed, like I know how to actually apply it and like what order to take it in.
Right. That is the main confusion for those people who are looking at it for the first time
Yeah.
because they don't know how to write the ratio only. So then after that, it's very confusing.
Yeah.
So we have Mn, let's say, and G is the centroid here.
Hmm.
And we say this is D. And this line is not parallel, so we can extend it and it will meet it somewhere here at P, right?
Yeah.
Okay, great. So now we can do Menelaus theorem directly here, right? For point P,
Hmm.
correct?
Yeah.
We'll get AM by MB for this one. And
Hmm.
then we'll imagine P to be somewhere inside and say BP by CP, right?
Yeah.
And then we'll say Cn by En, right? Are you understanding?
Yeah.
Okay, so we are getting this. Uh, right. Okay. Uh, Also,
You can apply it on triangle ABD too, right?
yeah, we can actually. We can apply it on that triangle also. I'm just thinking, is there a
Yeah.
nice way to get it from here? So, uh, Okay, actually, maybe it is better to do it on ABD. I will apply Menelaus on ABD, okay?
Mhm.
This was for triangle ABC, right?
Yeah.
I'm not getting any ideas right now. I will see what comes in ABD, okay? So
Mhm.
the first ratio is same, AM by MB, right?
Yeah.
Then the second ratio is BP by CP, is PD, right?
Yeah.
BP by PD. And the third ratio is DG by AG, right?
Yeah.
DG by AG is equal to 1, right?
Yeah.
But now one thing that we know is DG and AG ratio because it's centroid, right?
Yeah.
So we know that DG by AG will be 1 is to 2, right?
Yeah.
So we can say 1 here and 2 here, right?
Yeah.
And we can say basically that B BM by AM is equal to BP by 2 DP, right?
By two
I'm
DP.
just taking this to the other side, that's all.
Yeah. Yeah.
This is coming.
Mhm.
And BM by AM we have gotten, right? So notice that the thing that I want to prove can be rewritten by dividing it by this thing, right?
Yeah.
So if I divide the RHS, I will get CN by AN
Yeah.
plus AN gets cancelled and BM by AM, right?
Yeah.
Is equal to 1. This is what I have to show, right?
Yeah.
And I already have BM by AM is BP by 2DP, right?
Mhm. Yeah.
So BP by 2DP here. And can I also say something about CN by AN? Maybe we can. Right. So now think about it. Now I have to do Menelaus on a different triangle and triangle ADC.
Yeah.
See, that will give us CN by AN because that will connect it to AG and GD again.
Yeah.
Do you realize what is happening?
Yeah.
So if I do on ACD triangle, I will get the ratio AG by DG multiplied by DP by CP, right?
Mhm.
Multiplied by CN by AN is equal to 1, right?
Yeah.
Now AG and DG ratio is again 2 is to 1, right?
Yeah.
Correct?
Yeah.
So we get CN by AN is equal to uh, CP by 2DP, right?
Yeah.
Correct, no?
Yeah.
And now I'll put that here, CP by 2DP here, right?
Yeah.
And BP plus CP by 2DP I'm getting, right?
Yeah.
So I have to show that BP plus CP is somehow equal to 2DP. That's what I have to show.
B plus
Correct?
CP 2D. Yeah. Okay.
But D is the midpoint of BC, no?
Yeah.
So it's obvious, no? Because B to P is actually DP plus BD, right?
Yeah.
And C to P is actually DP minus CD.
Yeah.
So BD and CD are equal. So they
Yeah.
get cancelled and it is 2DP, right?
Yeah. Okay.
So remember in this problem, actually we didn't do it on triangle ABC, we did it on the other two triangles.
Yeah.
And when we wrote the ratio nicely, then we looked at what we have to prove and it is coming.
Mhm.
And you have to use the fact that it's the median at the end, and you have to use constantly the fact that centroid divides the median in the ratio 2 is to 1.
Yeah.
Are you understanding?
Yeah. I
Hmm.
tried like drawing CG out like the other
Hmm.
median and
Hmm.
then tried applying like Menelaus theorem, but
Right.
um would it work doing it that way too? Or
Like you are drawing the other median,
yeah.
but the reason it is not working is because it's not required for the question. No?
Yeah.
Like actually, they didn't mention anything other than the A median, right?
Yeah.
See, there is M and N are points on ABC. Show that AM, AN, CN. Okay. They have not mentioned anything except G lies on MN, right?
Yeah. Mhm.
So the other median is just making our figure worse, no? A little bit.
Yeah.
It just doesn't help us. I mean, I can't see anything directly. Maybe there is a way, but I don't know yet.
Mhm.
But this way is clear, no?
Yeah.
Okay, fine. We can discuss Shiva's theorem also if required in the next class. But
Okay.
why did you decide to discuss this? You were having some trouble with some questions.
Yeah. Like every time I learn it, I
Hmm.
can't apply it when I try to do it
Right,
like
right.
something where there's like a lot of like
Yeah,
lines, triangles.
right. The same pattern is there for Shiva's also. So
Yeah.
the same pattern of ratios, okay?
Yeah.
So don't there's nothing new in Shiva's. In Shiva's, it's actually easier because all the points are inside. The three
Yeah.
lines are concurrent, right?
Mhm.
So exactly same way you have to go in clockwise order and write the ratios. Okay.
Mhm. Yeah.
Okay. Next class we'll continue with our regular stuff then.
Okay.
Uh, okay. I'll see you next time then.
Okay. Thank you. Bye.
Bye.